Hello, everyone. My name is Dan Horowitz, president of Camp IT Conferences, and welcome to a Security Architecture Best Practices for Securing Applications, Containers, and Platforms webinar. We've been hosting enterprise IT conferences for 36 years, and due to the current environment, we are all of our offerings online, which creates great opportunity for IT professionals to join us from around the world. Today, our audience consists of information security leaders, practitioners throughout the world. Camp IT has always been about community and supporting one another. So feel free to connect with me on LinkedIn, and if I can be of help to you during this challenging time, I'm more than happy to open up my network to you. Feel free also to ask questions via the chat bar. I'd like to thank Saltworks and Arasi for presenting and sponsoring this webinar, which will provide you with practical advice to address challenges of securing applications, containers, and platforms. The goal is to make sure this experience exceeds your expectations. So feel free again to ask questions via the chat bar. I'll give you the speaker's contact information after the event as well. That way you can continue on with conversation and dialogue. Let's introduce our speaker. Dennis Hurst is the founder of Saltworks Security and Arasi Company. He's been at the forefront of application security and software development for more than 30 years, with extensive managerial experience across all aspects of software development lifecycle, including DevOps, testing, QA, product strategy, IT operations, etc. He's also been a trusted advisor for application security programs for Fortune 500 companies across every industry. And he's also an influential member of security and software industry associations. He's a founding member of the Cloud Security Alliance, where he co-authored the first two versions of the Application Security Guidelines and is an advocate for the OWASP project. Let's welcome Dennis. Dennis, thank you for joining us.
Great, thank you very much. I appreciate you having me. Very good, let me share my screen. And Dan, if you would just confirm that you see the screen okay.
I see it just fine.
Great, okay, very good. Thank you for having me. Again, I appreciate it. So today we're going to be having a discussion on security architecture, specifically focusing around best practices for secure applications, containers, and the platforms that those run on. And we're going to be going over a pretty broad array of topics. So I'll jump right in and then be happy to take any questions as we go through. And we'll also have a Q&A time at the end of the session as well. So just as a bit of introduction, Saltworks is an application security company. We partner with organizations to build world-class application security programs. What we mean by that is we understand that properly securing applications, and that's not just the writing of the applications, but how they run and the environments that they're in, really is very much a team effort. It's a program that spans from architecture through development through operations. So we work with companies to help create that integrated security program. As the introduction said, I'm the founder and president of Saltworks Security. We are a joint venture with Arasi Software, which is an industry leader in the testing, automation, DevOps space. So it's a great partnership. I'm also an industrial engineer by trade, which is probably why I like process so much. I've got about 25 years plus of experience in development and networking, about a little over 20 now in application security specifically. I was also the original developer of a product called WebInspect, which some of you may use. It's a tool that's used for assessing web applications and is still sold by Micro Focus, and actually we still are an active reseller with that. And then other things, I'm husband, dad, dog owner, and like to ride motorcycles, probably more than I should. So enough about me. So first up, I wanted to talk briefly about why is there a shift to DevOps and container and agile very quickly. I think that sets the stage for why does this relate back to operations and why you need to think about it from a process perspective. Certainly not an exhaustive chat of DevOps or any containers, but just a brief sort of laying of a bit of foundation. So one of the challenges that security teams have with DevOps, generally speaking, is that we typically view it almost as chaos. So having been in application security for years and development longer than that, one of the challenges it's very easy to see lots of development teams with lots of applications, putting them on lots of servers, running them in lots of environments. And it can seem like this very large, disorganized thing. In reality, what's usually happening is components are being built, and those components rely on other components and other systems. So it's not chaos, but it is a bit chaotic in that we have this web of interconnected and interdependent systems. That becomes particularly challenging for operations teams, because now you have these what development would call loosely coupled systems, which simply means that they can communicate with each other and the systems can change over time. But at the same time, they are still coupled and the business is coupled together. So when you start looking at securing that, or how do you manage those servers and how do you manage that infrastructure, it gets very complicated very quick as we start going down this road. So some of the big reasons, excuse me, some of the big reasons that we as a development community and as an application, people delivering applications are moving to DevOps and some of these more modern ways of running applications. A lot of it honestly is driven by business. It's just some simple business realities, and having been a developer most of my life, I can tell you I've been the victim or the cause of some of these pains. The reality is, according to a lot of studies, and there's many of these, I just picked a few, most projects have challenges. Roughly, according to this Standish group, about half of them are challenged at best, which means that they have problems and they're probably not going to achieve their goals. About 15% will just straight up fail and be considered a write-off, and only 34% would be considered a success. And given how much money we spend on these projects, that's a concern. That's a serious challenge. If we dig into why do people miss their project schedules, what hurts those projects, what hurts the business, and then kind of what's led us to DevOps and these more modern ways of developing applications. It's a lot, and these are really common. I can tell you as a developer, I have, again, either caused or experienced all of these. So the biggest one being a missed focus. Very simply, sometimes we just build the wrong thing. We take on very grandiose projects. We spend inordinate amounts of time developing them, and either we built the wrong thing, or more likely the world changed underneath our feet. So we deliver something that a year ago would have had value, but today doesn't for whatever reason. We run into content issues. So we run into challenges with changing requirements. So we're trying to build something and the requirements constantly change, so we never actually ship something, which is a constant challenge. We run into skills gaps, and this is one that I really harp on a lot, where we build something and we don't have the teams necessary to support it. So I'll use containers as an example. A lot of developers love containers right now. I think it's a good way to run an application, but there's not a lot of great training out there on containers. So as an operations team, you may not have the people that know how to run applications that are in containers or manage them. So that could be a case where we would be setting ourselves up for a skills gap. We also have executive issues. This happens all the time, either just unrealistic schedules. So sort of saying we have to build, a space shuttle and we got to have it in 2 days. You just can't do it. So we miss the mark, or executives just change what their expectations are. So a lot of calls for failure in IT, and this is a general statement about IT as a whole. So certainly been a victim and a cause of some of these problems personally. DevOps seeks to alleviate a lot of these things. And when I say DevOps, I'm talking about actually DevOps as a delivery mechanism, Agile as a development process or methodology, and containers as a complementary solution to that mix. So kind of putting all three of those things into this greater bucket of DevOps. Very simply because we deliver value faster, meaning we deliver value to the customer or our business in smaller chunks. So we code faster, we code smaller sets of data things, but we deliver them faster. And in concert, we come up with automated ways to test and deliver those faster. The whole goal of that is to get value to our customers, our business owners, for example, more quickly. So if we built the right thing, they can get value from it quickly. And if we built the wrong thing, they can correct us fast. So we have this term we use a lot called fail fast. It's better to spend a week building something and do the wrong thing than to spend a year doing the wrong thing. So we want to be able to deliver value or fail quickly in an iterative process. So over and over and over and over again. And that's kind of one of the key goals and values of DevOps, is that very simple thing of let's deliver small incremental value over time. Don't go for the big bang theory. Don't deliver the whole thing in one huge shot. So that's kind of a brief discussion of why we do DevOps, why the shift to it, why it's important. Now we get into the really complicated discussion of how do we secure all of this stuff? Because as things move faster, it's really easy to get out of control. So now we talk about what are the technical challenges with securing these systems and putting a proper architecture around that. So some of the problems is we have to go back and look at where do applications come from? And when I talk about applications, I'm not just talking about something that a developer writes. I'm really talking more about systems. So as IT professionals, we run systems. They do things for end users. That could be a mail server. It could be a custom web application. It could be a billing system. It could be anything. All of those things are applications, or many applications typically. So they're made up of a combination of things. You've got your server, you've got your application server, whatever it is that's running it. And then if it's custom code, you've got your languages that you wrote it in. You have huge arrays of open source software that's running as part of your applications, virtually always. And then you finally have your custom stuff that's on top of it. And as a hacker, I kind of don't care. I really want to attack the entire stack, so I don't care. So when we think about security, we have to think across the entire stack of what is this thing that we're running, this system that we're running, or this application we're running, and where are we going to get attacked, and then how do we start to defend that? So when I think about that, I typically think about it in terms of how did we get a system into production? So what led us to that point, and what should we have done along the way as we were creating or purchasing this system? And then I kind of make a matrix out of that and say, okay, well, there are things that are going to happen along the way. So for example, we've got the server, we've got its configuration, we have open source software, our code, our application, and then fundamentally our business logic. So as we look across that landscape of how did we get there and how does an attacker hit us, we really find that people have flaws or mistakes that they make all along that life cycle, along the entire evolution of a system that we put into production. On the environment side, and typically this would be thought of as architecture, it would live in the architecture team, or it's going to live in the infrastructure team. It's the environment. When I talk about environment, what I'm talking about is all of the tools and technologies and systems you give your developers or the people who are taking off-the-shelf applications and systems live into production. What are the tools that you give them so that they can fundamentally do their job better? So a common example of that might be a single sign-on solution. So you've got a solution that manages multi-factor authentication, and if that can be done consistently across your enterprise, that is an environment that you're giving that the developers can use, or people who are buying external systems can use to create a more secure environment. So we think about environment issues. We think about design issues. This is just where we design things wrong. We think about code flaws where a developer just makes a mistake. A lot of exploitation occurs here where a developer didn't really design something wrong. They just made a mistake, and it happens. We then get into lack of testing. So if we're not doing all these first three things well, hopefully in our testing, we figure that out and we fix it quickly and make it better for the future. And then once we're in production, we find lack of monitoring or proper defenses, especially as we begin talking about modern applications that run in Docker containers and that change very rapidly. It's really easy to not monitor and then respond to attacks. And we're going to kind of dig through each of these as we go through. In each of these areas, there are kind of major technologies or activities that you want to consider to ensure that you're creating a secure application or deploying secure systems with very similar kinds of challenges. I'm going to go fairly deep as we go through the presentation into specific ones of these, and the ones that I've chosen really are around places that we just see a lot of mistakes. Some things people generally are good at. For example, authentication, most people are pretty good at now. We understand multi-factor authentication. People are pretty solid with that. So I'm not going to spend a lot of time talking about authentication. It is absolutely critical. It is absolutely important, but most people are pretty good about it. And it doesn't radically change as we go to more modern ways of deploying. You do have to use it, but it doesn't radically change. There are some things, though, that do change. So things, I'm going to focus on things that are unique or more challenging as we move into more modern ways of developing and deploying applications. So DevOps, Agile, containerization, those kinds of areas. So again, the environment things are the things we're going to give our folks that are developing applications or deploying COTS off the shelf systems. What are we going to give them to let them do their job better and to give them an environment where they can be secure? Some of those things include proper inventories, so just understanding what applications exist. Encryption, we're going to talk a little bit about encryption and get into that. That's actually a place where you can add massive value. Not a lot of people do it well, but if done well, it can really add security value to your enterprise. Tokenization, we're not going to spend much time on. Again, authentication, folks are good at that. Development training, there's good standards around that, so we're not going to spend a lot of time there. We will talk a bit about open source code and how that affects all of this, so all those open source libraries that are out there. We're going to get into talking about design and architecture. Just as a quick note on design, I typically break down and talk about two separate things. There's architecture and there's threat modeling review. So architecture is asking, is the system that we're deploying, developing, buying, whatever it is, does it comply to our standards? So our architectural guidelines and standards. So for example, if we have an architectural standard that says we want to use a particular authentication system, a particular multi-factor type system, does it comply with that? That would be an architectural review standard of, are you using the appropriate controls and mechanisms? That is distinctly different from threat modeling. And the goal of threat modeling is to understand the system as it is being built and deployed, its interactions with other systems, and the inherent risk of that system. So for example, we'll talk about this more, but if you imagine a credit card system, something that takes credit cards and processes those or stores them, let's go to the extreme, and it stores credit cards, there is inherent risk in that. Regardless of the technology, regardless of if it's off the shelf or custom code, that is risky. So threat modeling's goal is to uncover those risks and show those threats, which is where the name threat modeling comes from. We're modeling the threat. We'll talk a little bit about open source analysis and static and dynamic analysis. Those again are very mature industries, things we know we're good at. So we'll talk briefly about them, but we're pretty solid there. We'll talk a little bit about some of the other testing methodologies we can bring to bear, like dynamic and dynamic analysis and penetration testing. And then we'll get into production. So our goal then in this for the rest of the talk is going to be to cover those areas and deep dive into a few of the places where where people seem to have challenges or just where the technology is changing a lot. So let's talk first about the architecture and the environment. Again, this is that area we're talking about. How do we give the developers a safe place to develop an application? And one of the first things, and this is going to be really simple to say and really hard to do well. The first thing you need to have or you need to strive toward is a good system inventory. You need to know what exists in your network, what exists on the internet that you own and you're supposed to be securing. There's a number of things we can do to do that. Sometimes people have CMDBs where they keep artifact histories. There's discovery that occurs to understand internal systems. One of the places that we find the biggest challenge is understanding, again, what exists on the internet. So what is accessible to the rest of the world and potentially could be exploited. So I'll give an example, and I'm going to, as we go through this, I'm going to show some different tool solutions that we use in our practice as an application security company. There are other good ones out there. Be happy to talk to you about the pros and cons of different things. I'm just using these really as an example of what I'm talking about. So let's talk first about some of the inventory of understanding what exists on the internet. There are systems out there. For example, I'm using Bit Discovery, which is a really effective tool that we like to use. With solutions like this, I can give the solution a domain name. For example, just for testing, I gave it who.int, which is the World Health Organization's primary domain, and said, okay, what can you tell me about that? So, and these systems are simply going out and looking on public records. I say simply, that's bad, but they are going out and looking on public records and gathering publicly accessible data. So they're not hacking, they're not scanning, they're not doing anything crazy. They're using public sources to gather and learn what they can learn about the company. So if, for example, if I were working with the World Health Organization, in about 5 minutes, I would have found all of these other domains that are also linked to the World Health Organization in some way. And immediately it popped up in my case and said, hey, there's 28 additional domains. Do you want to add those and go see what's going on there? So I said, yeah, let's go ahead and do that. So we do that. And notice all I did was give it the base domain. So pretty simple stuff, again, using open data sources. When it did that, it went out and showed me all of these other assets or other domain properties on the internet, domain names specifically, that were linked to the World Health Organization. So some of these look odd, if you will. I started wondering, well, why are they there? And you can imagine if this were your company and you were linked to all of these other websites or domains, you might want to know why and what's the risk there. Like, is somebody hosting your stuff? What's going on? In this case, it was pretty simple. It turns out this I believe gentleman that registered the original World Health Organization domain went out and they were the domain registrar, or it's their registration email that was used to register all of these domains. So the question you would want to ask is, that could be perfectly valid. It may just be that this gentleman also did a bunch of other stuff, and that's fine. They could be related, but it's worth asking you the question, what are they? Is it something you need to secure? Could it be somebody that's cyber squatting? So could there be a fake website there? Again, it goes to this whole idea that you need to be using some sort of system to understand what exists on the internet, what's public, to give you a scope of what all needs to be secured. So that's one of the areas that, especially from an architectural perspective, we see people really having some challenges, is understanding what their internet presence is truly. And again, there are solutions that do a great job at finding that kind of thing out. It's a little scary, actually, how good they are. The next thing we want to talk about, where we see people having real challenges and we see opportunity to add a lot of value as a company, especially as people move to containerized, compartmentalized applications. Again, be they COD systems or custom code, well, it doesn't matter, is around encryption. This is another area where people tend to have opportunities that could be much, much better. So when we talk about encryption, there's really some newer methodologies of encryption that are available that are very, very powerful. I'll give you an example of this. If we take, and we're going to talk about format preserving encryption, because it really does go to how data is stored and transported and how we can use it. So, and again, this is a tool that you would give your developers. Your developers can absolutely not do this on their own. This has to be a corporate level initiative. But what format preserving encryption in particular does, and that you can give your developers the ability to do, is it can take data. For example, if we take a tax ID, which kind of looks like a social security number, if we encrypt that in a traditional way, so for example, using AES, what we get out is this very convoluted looking string that is the encrypted data. Likewise, if we take a full record, like first name, last name, social security number, date of birth, and AES encrypt that, we get an equally convoluted looking string. It is encrypted, that's great. The challenge is the data that's within it is not going to go into a database very well. So if this is data we need to store, so for example, if this were my social and you needed to store my social, you're going to have a really hard time getting this AES data into Salesforce, for example, or some off-the-shelf software, or even custom code. With format preserving encryption, what it allows us to do is take the data and encrypt it. And the reason it's called format preserving encryption as opposed to just encryption is that it preserves the format. So if you notice, the format preserving encrypted data looks like, meaning its format is the same as the original data that we started with. If we take, first name, last name, and we format preserving encrypt that, if you'll notice, the data structure still looks the same, except the data itself is just encrypted into strings that still look the same. So if we were to take this data and try to insert it into a system, Salesforce, for example, could be a common one. If we inserted that into Salesforce, that would work just fine because it still has the same format, it passes validation rules, everything's fine. What this allows us to do is go into existing systems, store the data encrypted, and then only things that need to decrypt the data can pull it out and actually use it. So it allows us to encrypt data in systems that exist already and not break our systems. So all those web services, all those web applications, all those little microservices that are running around that touch this data that's encrypted, now you don't care because it's encrypted. So as opposed to if we send the actual information through, now we have potentially PCI compliance issues, we have privacy issues, we have all kinds of issues. So this is a technology that can really help. But again, this is a corporate level initiative, something somebody has to do at a high level, certainly. And that's a discussion, a more in-depth discussion of a format preserving encrypted is a few hour long conversation, but we'll be glad to go into that more deeper if you'd like to. But that is a technology that's very, very helpful from an architectural perspective. Just a few more examples of how that data gets encrypted. This is just some more examples of that. One of the common examples as well is test data. That is a challenge. Again, as we go to DevOps, one of the tenets of DevOps and this rapid development life cycles is we need to do automated testing. It's really nice if we can test with something that looks like production data. So we can use this technology, the format preserving encryption, to do format preserving encryption on our data. For example, James Potter with this social becomes this string that I can't say, but it still looks like a name with a number. And we can use that for our testing. So the next topic we want to get into is the actual software development lifecycle. So we're talking about architecture of applications and containers and how do we develop software. One of the big things there is how does a security team get into the software development lifecycle in ways that increase security so that they actually deliver secure applications to you. And you can monitor and know that it's going on. And this is going to be more process related as opposed to a tool or a technology. It's more a process and practices. And what I'm going to do is go through the way that we approach it and things we do along the way and we see value. Again, not a lot of tools. We're not going to talk about a lot of tooling in this. It's going to be more the practices and the areas you want to make sure you focus on to help your developers, to help your vendors give you more secure applications so that as you take those live and you need to defend them, you can do it. So we start out, the first thing we typically do is look at your policies and your procedures. Pretty simple stuff. Policies are, we think of those as the rules of the road. These are the things that you have to do in order to deliver a secure application. So if you, again, use a two-factor authentication system, that would be a policy that all applications should use your two-factor authentication system. And if they don't, they need to have a really, really good reason why they don't. And that probably has to be approved. So policies are those rules of the road. They tell people, what do you have to do to go live? And they should be very clear. That's one thing we see that's people make a mistake with a lot is their policies are overly verbose. They're long-winded. They're abstract. They don't tell people what to actually do. These should be very much, policy should say, what do you want them to do? So very much verb action based. Use XYZ multi-factor authentication system. It should be very prescriptive. Do this thing and some way of validating that it's been done. Procedures then are the how. So if you're going to tell somebody to use a particular multi-factor authentication system, or if you're going to tell them that they need to run static analysis scans using a software like Fortify to verify they don't have code flaws, you're going to give a prescriptive thing for that. So it's going to say, if you're using .NET, here's how you need to use this technology. So if you're in Java, here's how you run a Fortify static analysis scan, or a Sonatype open source analysis scan. So it's those prescriptive things that tell people how to do something, as opposed to the policies. Policies are, what are the rules of the road? The procedures are how to do it. It's important to have both of those, by the way, because your procedures will never cover every use case. Your policy should. Your policy should say, what are the things that need to be done? And the developer may have to achieve those goals in different ways. And that's fine. We want to minimize it, but it's okay. Procedures, on the other hand, are, if you use .NET or if you use Java, do this activity. And it's a way to help the developers and help the people that are doing systems to do their job faster, better, and more consistently. Third thing, and I actually put this first on the list because from a time-wise, it's the first thing. If you really don't know if your policies and procedures are comprehensive enough, there's a thing out there called an Open SAM assessment that can be done. This is an open, which is where the name comes from. This is an open assessment of your maturity as a company. It's based on best practices from the industry in general. It's sponsored by OWASP, or the Open Web Application Security Project, which is sort of the de facto group in our community. Very good process. You can do it yourself. You can have a consulting company like us help you with it. The goal of that is very simple. It's to understand, are your policies and procedures and the things you're actually doing in line with industry best practices? So if you have doubts about your policies and your procedures, strongly suggest a maturity assessment. Again, we'd love to help you with that, but it is a great first step. Even if you do it on your own, if you ever want to link to it, I'll be more than happy to send that to you. Once you've got those policies, now it's time to give people the tooling they need to do their job. So you've got the policies. Now you're going to do things like set up and configure your encryption standards. So if you decided to go with format preserving encryption, like we talked about, as a tool that you give your developers, we're going to stand it up, install it, configure it, make sure it's all working correctly. If you've got authentication authorization systems that are standardized, we want to make sure those are well documented, up and running. We want to make sure that logging is being done consistently and well across all applications. Those are kind of things that we would want to make sure you're doing to ensure that if you're ready to help your developers and your people that are buying software and implementing systems take those live well. And again, we've got some software solutions like, again, data encryption and voltage is one that we happen to like that does a great job. We also look at logging and event correlation, and how do you, I'll talk more about this later, but how do you create a logging environment that if you come under attack, you actually know it's occurring? Turns out that is really challenging with application security and container security, because they are somewhat custom, and they're also sort of, in the case of containers, they're also containerized. So it's challenging at times to get that data out and use it well. So that's kind of that second major step or phase is going to be around implementing that infrastructure, getting all those components in place and standardized. The next area we would go into is design. So this is when we're actually designing a particular system. Up until now, we've been talking about practices that are kind of corporate or global. They're things you do for the company, sort of holistic. Now, when we get into design, it's what is an actual team that's going to go buy something, build something, install something? What do they actually do? How do they ensure security of that system? First thing you want to do is architectural reviews. So you've got architectural standards. You want to have a standard way to do a review, to review checklists to make sure that they're actually following your standards, your policies. Next thing that they can do is threat modeling. Threat modeling is an interesting topic. Some people do it well. Some people have challenges with it. I'll summarize what threat modeling is and the value of it real quickly. An architectural review, like I mentioned before, says, are you following the standards that we have in place? So are you using our encryption system, for example? Are you running static scans with Fortify or whatever your solution set is? It says, are you doing those standard things? Threat model, on the other hand, says, tell me about your system and what are its inputs and outputs? What's the nature of the data that it's storing, and what is the inherent risk of that? And then that leads you to be able to ask yourself questions around how are we mitigating those risks? It's a fairly standard process to go through. There are different approaches to it. The one that we use is fairly similar to Microsoft's. It's a slightly simplified version of Microsoft's. There are others that are, it's more important that you do it than you use our approach. We certainly tend to like ours, but certainly anyone that works with you is great. So a threat model, if we kind of look at the output of a threat model, the most valuable element of this is going to be this drawing, which I'll walk through kind of what it means and it tells us. And I'll explain why we do it this way, because it is a very, very effective tool when you're understanding systems and needing to secure them. A threat model has a couple of interesting things. We have external interactors. So for example, this box is something that interacts with the system we're considering that is outside of the system. So whenever we're going to stand a system up and run it, be it one mail server or a cluster of web applications running in containers with Kubernetes that are load balancing, managing load balancing, whatever level of craziness you want to go to. For a threat model, what we want to do is first identify what is the system that is being considered. What's the thing we're going to evaluate for security and protect? And then we say that there are things that are outside of that system and things that are inside of that system. Anything that is outside of it either sends data into our system or we send data from our system outside to it. So in the case of this threat model, I've got a really simple little web application that takes orders and processes credit cards. The browser is that external interactor. It is sending data into our web server. When something goes into or out of our system, it's crossing what we call a trust boundary. That simply means that it's crossed from something we trust to something we don't trust, or we're having to establish trust. In the example of our web server, a user connects to our web server and has to log in to become a logged in user. When they log in, what we are doing is establishing trust. And we have to be very clear about what do we trust from that user now. Even if they logged in, that doesn't mean we trust all of their data, because they could be a bad guy, or a bad guy could be sitting between us and them and attack us. So we want to consider that whenever we see lines, these interaction lines crossing trust boundaries, that's a big red flag that says you need to think about this. Internally, then we have processes, which are the circles. Pretty simple. And we have an order application, so that's a little web service. Notice we've got another trust boundary here where we've got a container. So this is telling me, hey, data is flowing into your container, this container, like a Docker container, for example, that's running my little web application, and data is going out of that Docker container out to the outside world. So I need to know that, especially for containers. So if you notice, our web server is kind of sitting out here by itself in our data center, but the container, I'm thinking about it in a different way. I typically do that because the container can be run anywhere, theoretically. We could run it, we could fire it up any place we like. So given that we've got this little object, this binary chunk of stuff that is a Docker image, for example, and I can run it anywhere, I want to know that when that little thing gets fired up, it's a full-blown application. It's got an operating system effectively in it. It's got applications. It's doing things. It could be opening ports. It could be communicating outbound on ports. So we typically think of those as not necessarily higher risk, but things we need to consider. So that's why we put a trust boundary around it. And then again, we have our data going out. So if you notice, last thing just for completion, we have a data store where we store data, which hopefully you'll notice about this is super simple. It is very simple. We have external interactors. We have interactions between systems. We have processes. We have data stores, and we have trust boundaries. And that is it. Those are the only tools we use when we do a threat model to diagram it. There's a reason for that. The reason is we want simplicity and clarity when we talk about a system, because if I get an operations person and a developer and a security person all in a room, we will frequently all use the same words to describe absolutely different things. So we can't have that when we're doing threat modeling. We have to be painfully clear. So the way that we achieve that is through simplicity. We only have those basic elements. So if we all can only use very simple words, it makes us all be very clear, and we articulate how we're defending the system. And clarity and security are good friends. So that's why we like threat modeling so much. It's not technically that complicated, but it is of huge value. So once we move past sort of the design phase. Now we're in the traditional development life cycle. This is kind of where developers live and breathe. It's in that DevOps, build it, test it, deploy it realm. So I consider this everything, after design, but before it's in production and being monitored. It's that traditional DevOps lifecycle. What we're looking at there are kind of the tools that probably most people are fairly comfortable with. We have our pipelines, we have solutions that we use as part of that, like static analysis. Again, Fortify is very popular when we use it a lot. We have dynamic analysis, things like WebInspect, which obviously I'm fond of because I helped write the first versions of it, but there's other good ones out there that are commonly used in concert, like Burp. There's open source analysis tools. This is one that's frequently overlooked, by the way. Many people say they don't use open source tools. As a developer, I can tell you, you almost positively do. What's happened in the development world is that a lot of the libraries that you would think are part of your development environment, like .NET or Java, a lot of the libraries that are used as a core part of those are actually open source components. We find, well, rephrase that, we've never found a company that wasn't using a tremendous amount of open source components, and we've never found one that truly understood how much they were using until they did some testing, to include our own company. So I'll put ourselves in that boat along with it. So open source analysis is a huge one to look at, and that's a little more we're not more on the forefront, if you will, of security. Static and dynamic are well-established industries. Open source analysis, certainly on the newer end of that. And then penetration testing. Penetration testing, even in a DevOps cycle, is critical. We're looking at how do we have a smart human go break this application. Typically, this is cadence-based, so we probably don't do it with every release. It'd just be too expensive. We typically do that on maybe a quarterly or annual cycle, and in some more iterative approach to testing your applications. Also keep in mind as you think about the development of applications, keep in mind that security as a group we have people, processes, and technologies. That's how we do our business. So we have tools that we use, we have processes like audits, we have people. Developers have the same thing. They have the people that write the code, they have the processes they use like Agile, they have different technologies like Java, .NET, they have things they build with, they have things they test with. Application security, or this securing of applications and containers and things that live in them, really is a separate practice, even though it's frequently part of security, but it really has to have one foot in both camps. One of the things that's kind of a byproduct of that is that when you have people, processes, and technologies from both camps, metrics become incredibly important. What I mean by metrics are, can you measure your application security program and understand what's happening there? So if we think about for example, a DevOps pipeline. So we've got a DevOps pipeline. Some people show circles, some people show infinity signs, whatever your thing is. As we go through a DevOps process or development pipeline, we plan, we create. So we write code, we test the code, we package the code, we release the code, we configure the code, we go live with the code, and we monitor it. And based on what our customers and different people tell us, we plan our next release, and we kind of go through this cycle over time, building our application, which is great. The challenge is, if you're the security team and you now have to monitor this, you don't have one DevOps pipeline that has to have all these things in it. You have many development platforms. You have some people using DevOps. You have some people using Waterfall. You have some people going out and just buying off-the-shelf applications. You have some people having things built for you. You have all different ways that these systems are being built. You need to have a consistent view into all of that. So regardless of the testing technology, or the technology that's being used to build these things, or where you're buying it from, you need to be able to bring that data into a consistent place. We have a technology that we have written, we use, called SaltMiner, that does this, and it really gives us two things. One is it gives us the traditional vulnerability management views, so just understanding what vulnerabilities do we have and where are they at and who's fixing them, kind of your traditional vulnerability management side of the world. And then the other side of the world is, how are your applications complying to your policies? for example, if you know that all applications need to run a static scan of an application every month or before it goes live, you need to know that they ran the scan. Separate from the fact that they have vulnerabilities, you need to know that they actually have those, that they've run those scans. So that's where metrics come into play, is to understand those two key things. One is, what are our vulnerabilities? Very traditional model. And then additionally, are we compliant, or have we run the scans and the test and done the things we need to maintain a secure process? So it's measuring the process and measuring the vulnerabilities. The last thing we get into is monitoring. Monitoring is particularly challenging when it comes to applications, especially more modern applications. And we'll talk about that. So there's all the things we typically do to monitor and defend applications. We've got our things like intrusion detection and prevention systems, our IPSs and IDSs. We have RASP, or runtime protection. We have web app firewalls. A challenge that we run into, though, is logging, monitoring for logs. And let's talk about that for a second. So one of the ways that you know a system is under attack is that you know that you get logs. So for example, if I attack a web application, so you've got a web application, I start to attack it, the way that you'll generally know that you're under attack, and frequently, if I'm good at what I'm doing, and the only way you're going to know it, is that you're going to start getting some logs. So in your web logs, there'll be typically errors. Things will have crashed because I sent in some dumb input, and you're going to start seeing that. So you may see it a couple of other ways, but that's by far the most common. Or you'll see patterns in the web logs. The challenge we run into is that a lot of SIMs, one is, as developers write better code, less error-prone code, they start testing it properly, you're not going to have those errors because they're going to handle bad input better. So you're going to not get those errors in the logs anymore, which a lot of SIMs, though they're configured, rely on those for visibility. Additionally, if we're talking about applications that are in containers, those containers are starting up and moving around all over the place. So you have to have a way to monitor those logs as those containers move around. So when we get into container-specific security, let's talk about containers for a second, then we're gonna talk more about logging. But as we look at those containers, there's some kind of big questions we want to ask to decide, is the container appropriately secure? So the first thing we want to know is what's running in the container. So typically a container is going to run an application or applications. Even if it's a custom application, they're still going to be off-the-shelf stuff. So if I've got a Java website, I may have Tomcat running. There's going to be components that are part of that container. So first thing we want to know is what's running in the container. There are some good scanners for this out there. There's a number of those that will scan a container and tell you what's in it and are there known vulnerabilities with it. So if you're running an old version of Tomcat website, it's going to be able to go in there and say, hey, you're running an old version of Tomcat, it has known vulnerabilities, stop that, go remove that from it. There's some good commercial scanners out there for that. Next thing we need to know is what custom applications are in the container. So typically when we're running something in containers, we're running off-the-shelf stuff like Tomcat as a web server, and then we're sticking our application on top of that so that it does something interesting. In that case, the scanners, the typical traditional scanners, aren't going to be able to monitor that because they don't know what your application is. So there will be some blind spots there from the scanners, more around the custom applications. So that you're going to have to be able to track in separate ways. And that's typically part of your assessment, assessing applications, doing the security testing to make sure that everything you build is secure, including the stuff that goes in the containers. So that's protecting your custom applications. Next, we want to understand, how is the container configured? This is a super common mistake people make. There's also, the scanners are good at this, by the way, at telling us. It is common that people just misconfigure their containers. They open ports they don't need to. They just leave things unsecured. And maybe it's because a developer was doing something in their dev cycle and it got into production. There's all kinds of reasons people make these mistakes, but just basic configuration options. Again, scanners are good at looking at that. So that's something a good scanner is going to do a good job of. And then as we finally want to ask the question, where's it going to run? So when you certify a container to run, you should also be certifying where it can run. It doesn't mean it can run on the internet, obviously. You need to certify where does it run. This is going to go back to the threat modeling as well. So if you understand that something is being built in a container, you need to understand what are the assumptions about its context. So is it running inside my data center? Is it running inside my DMZ? What is it accessible to? What does it need access to? Threat modeling is going to help you build a model around what's in the container, what does it need to do its job, and what can you firewall it off from to protect it. So all of the things we've talked about around application security and the systems that we put into and make available to developers and people buying software really ultimately culminate in container security, because we're taking all of that knowledge and all of those things and putting them in a nice little container and then making sure we secure it. So they're all very, very interrelated to each other when you get into container security. Next thing we're going to talk about is event monitoring. So there are very traditional monitoring ways when we talk about SIEMs and how you take events and how you monitor those and how you have your SOC 1 and 2 and 3 analysts look at those. I'd strongly suggest that you look at some of the more up-to-date solutions that take data and do a lot of the work, the very tedious work that you would normally have a SOC 1 analyst do. And look at building statistical models or using artificial intelligence engines to analyze events and then correlate those and calculate the probability that the event you're seeing is an attack. Where this becomes important as we go to more modern applications, again, containerized or things that are shipping very fast and changing very fast, is humans, generally speaking, are not great at seeing as systems change. They don't keep up on those patterns. So if a container is running on one box today and another box tomorrow and moving all around all over the place, that may be triggering events. That's going to be a lot of noise for a SOC 1 analyst to look at. So they're going to be seeing all these events. If you can use an artificial intelligence engine to correlate these things and give you higher fidelity, now you can use your analyst to do more things that human brains are really good at. So evaluating events and asking business questions like, is there data here that I actually care about? Who should respond to this? What's an appropriate action? These systems also let you reduce the number of rules you have to write for your SOAR, because they're going to do a little bit better job, or we're going to be a considerably better job of firing events that need to be reacted to. So if you have less events you need to react to, you can have less SOAR rules. So again, looking at event correlation engines that are complementary to your SIEMs that give higher fidelity results in logging. Whole subject we could go into for hours, but it's certainly worth considering is how are you logging? How are you monitoring your logs? What are you doing with them? How effective is that program? Good. So just to wrap up, I know we're getting near the end of our hour. If there's some just big takeaways, kind of broad strokes things I would suggest. One is know your environment, know what exists. This is one of the most fundamental challenges we see people making. We talked a little bit about like how bit discovery and tools like that can help you understand what's on the internet. Understanding what exists in your in your environment is huge. Threat modeling falls into this category where we're understanding our systems and then understanding our blind spots. That is, knowing what you have is one of the biggest things you can do to help yourself. Second thing that I'd really talk about is giving your development teams the tools they need to do their job well and make their life easier. So if you can give them standard ways to do those really hard things like authentication and encryption, as an operations team, as an enterprise team, that's one of the best things you can do for your developers is give them the tools they need to do their job. Next thing I would say is measuring the security of your software development lifecycle. So having that enterprise view to understand, are your teams doing the activities which need to be done to ensure the security of your applications? Understanding that across the enterprise is huge. And then finally, looking at your monitoring. So again, looking and making sure that if application attacks occur, if people are attacking those containers as they move from system to system, is your event correlation, your SIEM, actually picking those events up? Are they actionable? How much noise are you getting? And potentially looking at some systems that help to make that world better. Those would be kind of my big notes to big takeaways. So again, I want to thank you for joining us today for this joint presentation between Oracy and Saltworks. As was said in the introduction, we're an Oracy company. We are a joint venture with Oracy, and very proud of the legacy that Oracy has around DevOps and the legacy we have around security. It's always exciting to be able to talk about where those two worlds meet, and we're excited to talk to you further. If you would like any more information, you're welcome to email me. You're welcome to send an email to any of our sales team. They'll be glad to get your questions to the right folks. But I did want to say thank you very much, and I appreciate your time.
Thank you, Dennis, for a great presentation. We do have one question, and that is, could you recap the 4 things in the threat models?
Yes, and if you'll send me a link, and this is going to be ugly because I'm going to switch through a bunch of slides. If they'll send me a link, I'll be glad to send them a sort of a cheat sheet deck on the threat model. But let me go back, and I know I just went past it. I apologize. And there's actually, so the things are, the first is an external interactor, and that is going to be something that interacts with your system, but is not part of it. So it's something outside of your system. The user of a website, for example, is an external interactor because they are outside of the website, not inside of it. Interactions are the next thing. So that's simply where we're sending data from one component to another. That's an interaction. The third one is a trust boundary. It's where data crosses over trust boundaries. One from the internet to an internal network, obviously, is a trust boundary. Next thing we have are processes. So these are things that receive, process, or transmit data. Keyword there, they're not storing data. And then the last one is a data store. So anywhere we're storing or persisting data. And there's a really good PowerPoint deck and PDF I'll be happy to send you if you'd like it, that goes through those in detail if you're interested. Great. Do we have any
I hope that helped. So, yeah, I don't see any other questions, but Philip, let us know if there's further information that you need regarding the question. If there are any other questions, feel free to chat them in right now. I will also give everyone Dennis's email address. At dennis@saltworks.io, correct?
It is, yes.
Okay. So everyone, thank you for joining us. And if you want a copy of the presentation, you'll see Dennis's email address in there, and just email him directly. Or I'm going to put another email address in there as well, and that's Don Anderson. And I have to tell you, I've had a real pleasure working with the folks from Saltworks and Oracy, high integrity individuals that, as anyone who knows me, I always try and vet out folks that we work with, but I can't say enough good things about them in terms of the thought leadership, the integrity, the decency that these folks all have. So please consider them when you have these challenges you're trying to work through, and feel free to reach out to Dan. You'll see his email address. Dennis, his email address is in the chat file as well, and they'll be more than happy to send you a copy of the presentation. And thank you to Saltworks and Oracy for presenting this. We hope that everyone stays happy and healthy during this challenging time, and feel free to reach out to me on LinkedIn if I can be of help to anyone on this call. I will of today a certificate of continuing education credits for today's webinar. So by the end of today, you should see that in your inbox. Also keep in mind some upcoming events, Data Analytics Strategies Full Day Conference on the 19th, as well as a data breach prevention response and cloud security full day events, and an automation, a moderated panel on automation on December 2nd, all of which can be located under upcoming events at campconferences.com. Thank you, everyone. We look forward to seeing you online in the near future, and hopefully on site in the not too distant future. Be well.
Thank you. Have a great day.
Thank you, Dennis.